Hello, today we are going to discuss about TCP/IP protocol suite. So in this we are going to learn about TCP/IP protocol suite, about its architecture and then the advantages and disadvantages. So let's first start with TCP/IP protocol suite. So TCP/IP stands for Transmission Control Protocol and Internet Protocol. The TCP/IP protocol suite is a collection of protocols that define the Internet, and it was developed by Department of Defense Project Research Agency (ARPA) and later known as GARPA. So the main aim to design this model is to provide end-to-end data communication, specifying how data should be packaged, addressed, transmitted, routed, and received in the network. So it is a project of network interconnection to connect remote machines. So we have the OSI model. Why we need this TCP/IP model? The OSI is the theoretical model, whereas TCP/IP is the practical model which we are using in our network. So TCP/IP is a two-layer protocol, the higher layer and the lower layers. The higher layer represents Transmission Control Protocol, which manages the assembling of a message into smaller packets that are transmitted over the internet. And the lower layer represents Internet Protocol, which adds the IP or MAC address to packets so that it gets to the right destination. So the TCP/IP uses the client-server model of communication, in which a client user requests and the server provides a service in the network. Next, the TCP/IP architecture. So the old model of TCP/IP consists of 4 layers, but its updated model consists of 5 layers: application layer, transport layer, network or internet layer, data link layer, physical layer, or the network interface layer. So each layer in TCP/IP model correspond to one or more layer of the 7-layer OSI model. This diagram shows the TCP/IP model, where it represents layers, protocols, and the protocol data units used by the TCP/IP. So first let's discuss about application layer. The application layer provides interface between the application and the protocols. So it represents application to access the service of the other layers. So it can access the service of other layers like transport layer, network layer, and the data link layers or the physical layer. So and it defines the protocol that application use to exchange data. Such protocols are HTTP, FTP, SMTP. So the HTTP protocol is to use transfer file that make up the web pages, whereas FTP is used for file transfer, and SMTP is used for the transfer of the mail messages and attachment. This Telnet, a terminal emulation protocol, is used for logging on remotely to network host. So the application layer protocols which facilitates the use and management of this TCP/IP network are DNS, RIP, etc. So example of application layers are Windows sockets and NetBIOS. Next is transport layer. It is also known as host-to-host transport layer. The transport layer is responsible for end-to-end delivery of data packets, and the protocols used by transport layers are TCP and UDP. We have discussed about this in earlier classes. So it performs functions such as multiplexing, segmenting, or splitting of data. And transport layer also add header information to the data. Transport layer arranges the packet to be sent in sequence. So it also adds the sequence number to the packets. Next is network layer. It is also known as internet layer. The network layer performs basic functions such as addressing, packaging, and routing of the data packet. So this layer holds the whole architecture together and helps the packet to travel independently to the destination. So the internet layer is analogous to the network layer of the OSI model. This is network layer. The protocols used at network layer are Internet Protocol, Address Resolution Protocol, Internet Control Message Protocol, or IGMP. So Internet Protocol is responsible for IP addressing, routing, and fragmentation and resampling of packet, whereas ARP is responsible for resolution of the IP addresses to the network interface layer address or the MAC address. So the ICMP is responsible for reporting error due to the unsuccessful delivery of the IP packets. So these are the protocol of the network layer. Next is data link layer. The function performed by data link layers are data framing, where it encapsulates the data message into frames and send over to the network. And next is addressing, where data link layer adds the MAC address with the data messages. And next is error detection and correction. It handles errors that occur at the lower layer of the network stack. For example, cyclic redundancy check fields. So these check the errors and then corrects the error and transmit the data in the network. Next is sub-layers of data link layer. Logical link control, LLC. Logical link control is responsible for establishment and control of logical links between local devices on a network. So LAN technology uses the IEEE 802.2 LLC protocol. And then this sublayer is media access control, MAC. This layer is used by device to control access to the network media. So as many network use a shared media, so management of the shared medium is necessary to reduce conflict. Such as in Ethernet, we are using CSMA/CD method of medium access control, so that there no conflicts will be occur in the network. Next layer is physical layer. It is also known as network interface layer or network access layer. So protocol are used to connect host to host and network to network. The network interface layer is responsible for sending and receiving TCP/IP packets on the network medium. So these include LAN technologies and WAN technologies. So the network interface layer is same as physical layer of the OSI model. This represents the TCP/IP models. It's working. Sending host and the receiving host, functions between the sending host and the receiving host. Next is advantages of TCP/IP model. TCP/IP model is a model which is operated independently, and it is scalable model, and it follows client server architecture, and it is used with number of routing protocols, and it can be easily used to establish a connection between the two compute. And disadvantages are the transport layer is not responsible for delivery of packet. It can't guarantees the delivery of packet. The model cannot be used in any other applications, and the replacing this any protocol is not easy. It also no clear description about services, protocols, and interfaces at each layer. So you can't use it as a teaching process. This is all about TCP/IP. Thank you.